So today we'll be looking into a very simple but effective program, something called as Seiperniski Gasket. Okay, so question goes in this way: design, develop, and implement recursively subdivide a tetrahedron to form 3D Seiperniski gasket. The number of recursive steps is to be specified by the user. So let's understand what exactly the problem is first. Okay. So what do we mean by Seiperniski gasket? Seiperniski is actually a person who designed this particular gasket. Okay. So first things first, we'll try to understand what a Seiperniski is. And this Seiperniski gasket should be divided recursively. That is the important thing. So what do you mean by divide it recursively? As we all know, recursive function is one function which will be calling itself, right? A function which calls itself is called as a recursive function. It's called as a recursive function. And whenever you call the same function again and again, whenever you call the same function again and again, is called as a concept of recursive. So first, what does the question say? The question said that we have to create a tetrahedron, right? So recursively subdivide a tetrahedron. That means we need to delete. I mean, we have to create a tetrahedron. Later, once we create the tetrahedron, we have to divide that tetrahedron into number of parts. Number of parts is something called as the number of subdivides. All right. So looking into for our understanding here, let me go with. Let's draw a tetrahedron. So first thing is, how do we draw a tetrahedron? So tetrahedron has how many sides? Tetrahedron has 4 sides. Tetrahedron has 4 sides, and in this 4 sides, 3 base sides or vertex. Basically, 3 base vertices it is, right? So vertices or edges, and the other one will be the apex. So basically, how a tetrahedron looks like, a tetrahedron looks in this way. This is a triangle, but still, yeah. How do I make it a tetrahedron? So the other side is not visible, right? So this is how a tetrahedron looks like. So this, I can say it as a top view. This I can say it as a top view. How about the side view? Side view is just a triangle, which I can say, right? So, or we can have, yeah, this will be the top view. If I just join these lines, so it will be a top view. So this will be the side view. All right. So this particular point, this is called as the apex, and the remaining 3 sides, 1, 2, 3. So these are called as base. I can call it as the edges, right? So we have how many triangles in a tetrahedron? So we have to see that we have 4 triangles, right? So these are the basic information which we are getting to know about the tetrahedron, because this particular program is a 3-dimension. So we need to also look into the width, that is the z-axis. We also need to see with the color. So we also need to look with the viewport. Anyhow, why viewport? Because it's a 3-dimension image. And we also need to divide. That means a recursive function has to be taken care. Then what else? And it is also a orthogonal image, right? So these are the important consideration which we need to take. All right. So first of all, what I need to do with this example is I have to create a tetrahedron. I have to create a tetrahedron of equal sides. Remember, a tetrahedron with equal sides. So let's say this is a side view. Let's say this is a side view. Whenever we have a tetrahedron, I'm dividing that particular tetrahedron. So how am I dividing it? So how we are dividing is take the midpoint of all the sides. Take the midpoints of all the sides, and you join it. Okay. So then how many triangles you got now per side? Initially it was just one side. Yeah. So later for single division it became how many triangles? 1, 2, 3, 4 triangles it became for one division. So similarly if I go for another division, what will happen? Take this sides, join it. Not only for this side, also join it for this side also. Similarly, join over here too. So this is the second division. Right? So I'll tell you again, the first division is, oh, sorry. What do you mean by the first division? First division is I'm dividing once, right? So I'm dividing the particular triangle once. So if you're dividing a particular triangle for n number of times, right? So this n is actually given by oh my god. Okay, so this n is given by whom? This n is given by the user, right? So this values. So n can be varying with 1, 2, and it goes on. Okay, if it doesn't give any sides, no side, straight away only triangle it will be giving it. All right. So minimum, in order to look into a 3D Seiperniski gasket, you need one division. So one division is per side of a tetrahedron, divide it once. How do we divide? Take the midpoint, then join it. This is one division. What about the second division? Take the midpoint of these second lead created triangles, then join it. So this is what? This is the second division. Similarly, what about the third division now? Third division is join all these things. I'll change the color. So join these, join this, join this. Similarly, all the sides you will be joining. And now I think you got to know why recursive is important here. Okay, so this is here. How many divisions? This is 3 divisions. How do I know? This is the first division, this is the second division, and this is the third division. So 3 division Seiperniski gasket. Okay, so any doubts till here, guys, with the understanding of the output? This is how our output looks like. Any issues do we have, class? Any questions? No, I guess not. We'll be moving on to the program. We'll understand how the program looks. Okay, this is a very small program according to your graphics. Actually, this complete laboratory program. This is the simplest program, right? So in order to understand how exactly, how it makes it as a simple is very, as I said, less number of values. We just need to create a triangle and divide it recursively. There is a catch. What is the catch? If you are not creating the values properly, what do I mean by values here? This sides or these values clearly, your Seiperniski will not be looking like a Seiperniski. That means it will no more be a tetrahedron. So important thing here is see to that you have given the valid vertex points. Okay, so I'll tell you how to remember these values and how to implement these values. All right, so very easy and simple way how to remember it. Let's understand. Let me clear this off. So yeah, so first thing is, where does the execution of a program starts from? The execution of a program starts from main method. So I have a main method here. So we'll get the number of divisions from the user before itself, because it is needed for us to calculate how many divisions we want, what are the, how do we divide it, how do we deal with. So number of divisions is needed, followed by initially try to give very small numbers, restrict to 1 to 5. Don't give 500, 600, because your program will become very slow. Okay, it needs to subdivide from beginning till end, and it becomes messy. So give the number of divisions from 1 to 5. Why? Because you need to explain the examiner that this is how the divisions are going. Okay, so number of divisions, get the values. So once you get the values, use the init method. Tell that I'm going to create a yeah, so initially what are the considerations? Where do I start from? Here we are not starting with anything, but still I collect the values of argument count and vector, because I need to start from, I need to create a window, right? So I need to get the initial init values. Glut init display mode. Here we have three. We are telling that we are using the options of these three. So as it is not involving with rotation, we don't want double buffering. Single buffering is more than enough. Why? Because we don't rotate the viewer or nothing related to movement, right? So single buffer is more than enough. Moving on to next is Glut Rgb. Glut Rgb stands for so red, green, and blue. Yeah, that means we are exclusively telling that we are using colors for our color model here. So next is, we are also dealing with the glut depth. That means it's a 3-dimensional image. So no rotation, no movement. We are using the colors. It's a 3-dimension. So you have to specify that my display mode contains these many important options. All right. So yeah, once you tell that these are the options for the display mode, then you go for creating a window, and that particular window should have a name. And what will that name be? That window name will be 3D gasket. So next, followed by, we have a function called as myReshape. Why we need, or why we go for myReshape is, as you all know, whenever I change the window sizes, it should be automatically adjusted to the window or the viewport. That's why we use myReshape function. We have spoken enough of these this myReshape function. See to that you deal with the same values as W and H. That means whatever the size of my created window, and whatever the height of that created window. I'll just show you. For now, I'll just take it as division 1. So here, whenever I increase or decrease my width and height of my display screen, automatically the image should also be getting readjusted. So that's why we use reshape function. Okay. Oh, what has happened? Yeah. So readjusting here is okay. What should I do if my width is less than height? You go for this particular ortho function. What if my height is greater than width? Then you go for these values. Okay, and once it is rechanged, call for repose display. That means call for calculating again. So that's about the my shape function. Next we have the logic of the program. The logic of the program is in display method. So we'll go to the display method. Okay, display method is, okay, first thing is clear whatever I have in my buffer previously, and whatever with 3 dimension I have, clear it. So once you clear it, whatever your display buffer had previously, it will all be taken off. So after that, load the identity matrix. So you need to draw with some projections. You're using some projection, so you go for load identity. Then after that, the things start, right? So after you know that you have to start from where to where, then you call the tetrahedron of n. Tetrahedron of n. What is this n? In main function n, we took it as 1, right? So that one value will be carried, right? So that one value will be carried. Yeah, so carried to where? Carried to the function tetrahedron. Now go to the tetrahedron. Okay, here it is. So I need to calculate the tetrahedron with how many sides? With n number of divisions, not sides, m number of divisions. So here we set the color as red, green, blue, and black. So 4 colors for 4 sides actually. These 4 are for 4 sides because tetrahedron has how many sides? We have 4 sides. In other words, how many triangles does a tetrahedron have? A tetrahedron will have 4 sides. Is it not? Okay, so if I take this as my value here, so I'll be joining this, and I'll be joining from here to here. Then again, I'll be joining from here to here. So I have how many sides? I have 4 sides. One, I set it with red. The other, I set it with green. And the other, I set it with blue. What about the basement? What about the base triangle? Right? So I also have the below side of these 3 sides. There is another side. Right? How does that side look like? So that side look like the base here. So it will be filled with which color? It will be filled with black color. That's how exactly it looks. Okay. So we have 3 sides and the base side. So 4 sides. That means how many triangles you need to see now? So how many triangles do we need to create? So we need to create 4 triangles. So one triangle with red, one with green, one with blue, and the other one with black. That's exactly what this code specifies. That's exactly what this code specifies. So tetrahedron is initially get the red color and okay, go with divide triangle with vertex of 0, 1, 2. So we have 4 vertex here, v of 0, v of 1, v of 2, and v of 3. This is important. Let us now understand how exactly we considered these 4 values. These 4 values, how did we consider? How did we see? All right. So the first thing is, so the reference point is 0, 0, 1 for the first one. So as you can see here, 0, 0, 1. So the first point, the reference is 0, 0, 1. And for the second point, it is 0, 1, 0. For the third point, it is -1, -0.5, and 0. And for the fourth one is 1, -0.5, and 0. These 4 values will determine these edge values. So these determine these 4 edge values. How do we understand these 0, 0 values? Let us now come into it, right? So let us understand. So 0 with x, y, and z value. So all these values come in the same. So 0, 0 with z is 1. always remember we are starting from our origin here. Okay, so 0, 0 means 0 with x-axis. I'll draw it with a bigger triangle here. So this is just a blueprint here. Okay, so this is my axis. So this is my x-axis. So what about this? This is my y-axis. And the z-axis is actually in this way, parallel to your view. Okay, so that will be the z-axis. So first thing is, what was the value initially? It was 0, 0, 1. So 0, 0, 0, 1. So x is 0, y is 0. X is 0, y is 0. And what about the z? Z is positive 1. What is positive 1 says here? I'm starting from here and it is towards the front of the triangle. That means this is the apex point. This is the apex point. So this value will be 0, 0, 1. This value will be 0, 0, 1. That means it will be the apex, the center point. So next is 0, 1, 0. Next is 0, 1 and 0. So what is the 0, 1, 0? 0 with x, 1 with y. That means this point, and 0 with z. So this is the point which is speaking now. So the second vertex is over here. So this is what? 0 with x, 0 with x, y with 1, and again z also nothing. So z is also 0. That means this is the top base point. Top or one of the base point. Let's assume this is the top base point. All right. So what will be the next one? Now you imagine this point will be what? Will be with negative x-axis, negative x-axis, negative y-axis, and 0 with respect to z. So negative 1, minus 0.5 and 0. So this point will be negative minus 1. So minus 1. So y value is pretty small here. So minus 0.5. And anyhow, it is the z value is 0, this point. So this I call it as left base. This I'll call it as left base. What about the other term here? What about the other value? The other value is pretty simple. Anybody wants to take a guess? It is on which side of x? It is which side of x? Yeah, continue.
Sir.
Yeah?
Positive x, sir.
Positive x. Yeah, so 1. What about the y value?
Negative, sir.
Negative 0.5. Next, what about z? 0. Z is 0. So this will be right base again. So these are just the names which I give. This is apex. This is for our understanding. So this is apex, this is top base, this is left base, and this is the right base. Okay. So this is the first thing that you need to create. That means you have now created. You have now created the. I mean, you now understood how the vertex look like, and now I guess you people can easily understand what are these 0, 0, 1, 0, 1, 0, minus 1, minus 5, 0, 1, minus 5, 0. I hope you people got it now. You people got it or not? I guess you people have got it. So
yeah, sir.
Excellent, excellent. So we'll come back. So GL color 3F, red color, select as a red color. Then divide the triangle 0, 1, 2. So which was the 0th one? 0th one was this, right? So this was the 0th one. So this vertex is 0, this vertex is 1, this vertex is 2, and this vertex is 3. So make it as a 1, then connect 0, 1, and 2 vertex. Then also consider how many divisions you want, because every side it has to be divided. Every side it has to be divided. So second thing is consider which color? The green color. 0, 1, 0. That is your green color. Which are the vertices which you need to look into now? The vertices are 3, 2, 1. So 3, 2, 1. That means the base one. The base one is making as green, but now I made it as black here. All right. So base. Now what I'll do is no issues. We'll just fill it in. Oh, with green, no issue. So the green one which he has put. So he will create the base next. That is 3, 2, 1, 3, 2, 1. Then colored blue for which one? 0, 3, 1. So 0, 3, 1 is this. So he's making this as blue. So this color as blue and this color as black. Okay, according to the code which I have created. So even if you look the example also, it looks the same. All right, red, blue, and black. Can you see here? Can you see the comparison? I have red, I have blue, and I have black. On the back of it, I have green. That means the base. So it looks the same, similar, right? At least for me, the colors seems similar. So yeah, so what is the first thing we have done now? Connect, not connect, just get the values. It has not been connected yet. So 0, 1, 2, 3, 2, 1, 0, 3, 1 and 0, 2, 1 will be those value which will be going to divide triangle. So you go to divide triangle for which value? For 0, 1, 2. That means 0, 1, 2. Let's assume my n value is 1 for now. Okay, assume that n value is equals to 1. So next we'll look into the value of 2 with the case. Okay, people are joining pretty late. All right. So yeah, so once I send these 0, 1, 2 values, 0, 1, 2 values to where? To divide triangle. Come to divide triangle. Divide triangle is actually accepting 3 values. So point A, point B, point C. What is point? Point is an array. See here, right? Point itself is it's an array. Point itself is an array. So array of array basically. So point of A, B, C. So 0, 2, 1, 0, 1, 2. Okay, 0, 1, 2 comes and resides here, and A, B, C. We create point V1, V2, V3. Why this point V1, V2, V3 is? This point we have to create V1, V2, V3. We'll try to understand what that exactly says. So for j equal to 0, j less than 3, j plus plus, V1 of j will be equal to A of j plus B of j divided by 2. So A of j, that means we'll consider the value 0, 0, 1, 0, 1, 0. Right, so 0, 0, 1, 0, 1, 2. Oh, okay. We'll draw it over here. So what were the values? 0, 0, 1, then 0, 1, 0, then it was 0, 1, 2. Second one is minus 1, minus 0.5, and what about the z value? It was this. So here when you see, what is V1? V1 was A. No. This was A, this was B, and this was C. So this is A, this is B, and this is C. So V1 will be equal to okay, basically V1 of j. So j value is 0. When j is equals to 0, so V of 0 will be equal to A of 0 plus B of 0. So what is A of 0? It is 0 only. What is B of 0? B of 0 is also 0. Okay, so 0 plus 0 divided by 2 is what? 0. So V of 1. V1 of 1 is what? V1 of 1 is 0 plus 1 by 2. 0 plus 1 by 2. So what is 0, 1 plus 1 by 2? It is 0.5. Next, V1 of 3, right? So V1 of 2, sorry. So V1 of 0 is done, V1 of 1 is done, V1 of 2. So what is V1 of 2? A of 1 and B of 1. So A of 1 is 1 plus 0 divided by 2. So what is 1 plus 0 by 2? It is again 0.5. So 0 plus 0.5 plus 0.5. These are my V1 values. Right? V1 array will be of what? 0, 0.5 and 0.5. Any doubts here? Any doubts here? I guess not. Next, we'll try to understand V2 of 0. What is V2 of 0, V2 of 1 and V2 of 2? So V2 of 0 is A and C. So this and this I have to consider. So 0 minus 1 is minus 1 by 2 is what? Minus 0.5. Next, 0 plus minus 0.5 is minus 0.5 by 2 is what? 0.25. 0.25. Then 1, 0 by 2 is 0.5. So 1 plus 2 is so 0.5. So these are the values. So what else? What about V2 of 1? Okay, anyhow, we straight away created this value. Okay, so this V2 straight away will be the same. Okay, so V2 will be, I have already written straight away, minus 0.5, 0.25 and 0.5. So what about V3 here? So V3 will be equal to, so V3 we look into the side of what? C and B. C and B. So C and B is minus 1 plus 0 by 2 is what? Minus 0.5. So next, minus 0.5 plus 1 by 2 is what? Minus 0.25. Then 0 plus 0 by 2 is what? 0. So we got V1, V2 and V3. So V1 is 0, 0.5, 0.5. So V2 is minus 0.5, minus 0.25, then 0.5. Then V3 is, this is V2, this is V2. V3 is minus 0.5, then minus 0.25, then 0. So by getting these three values, just see to it how we deal with it. Right? First value is 0, 0.5, 0.5. So 0 is here. What is 0.5, 0.5 now? What is 0.5, 0.5? 0.5 with x is over here. Right? So x is over here. Then sorry, y with 0.5 and z with 0.5. So x is 0, y with 0.5 and z is also 0.5. That means here, this will be the midpoint. Got it? So next is V2 is minus 0.5 minus 0.25. So minus 5 minus 0.25, that is negative here. Negative minus 5 and y is 0.25 somewhere here. And what about the z thing? Z term is also minus 0.5. That means somewhere here it comes. Minus 0.5 minus 2.5 and the value of here. All right. Next, what about the last term? V3 is minus 5, so minus 0.5 minus 2.5. So minus 0.5 minus 2.5. Then what about the z value? Z value is 0. That means this will be the axis. This will be the value because x is, this is 1, this is minus 0.5 and with the value and anyhow z is what? 0. So this will be the particular value, right? So yeah, one more thing here is y doesn't straight away come here. Your y actually comes somewhere here. Okay, so you can, okay, first v1, v2, v3 we have found it out. Once we found it out, then what is m minus 1. As my m is 1, 1 minus 1 is 0. So 0, V1, V2 will be sent. So which is V1, which is V2, which is V3? This is V1, this is V2, and this is V3. So these three will be sent with the points. So it will come here, again it will come here. So once it is done, it comes back here. So divide triangle of V0, V1, V2. So it comes here. Then again recursively it will be calculated. Once you come to see that m is now 0, m is now 0, right? So 0 is not greater than 0. That will be a wrong way. So if this condition will no more be executed, then it comes here. So else part, what does it say? Then else part will be whatever I have in ABC will be joined. So what it does is it will join from here to here, here to here, and here to here with the value what it sees. All right. So it joins this. Similarly, what it does, it's also sent to this point. It will also be sending to this point. So from here to here. So yeah, basically it draws the triangle, the sides also. So this is how it looks like. So it will join. This was V1, this was V2, and this was V3. Right. So here it will join this, it will join this, and it will join this. And there also it will put up some colors again. Okay. So similarly, that will be applied for all the three sides here. What about this, this, this? So it will join here, here, and here. Even on the other side also it will be joining in this way. Okay, this is my first division. Similarly, how many number of divisions you give, so many number of times it will start undertaking all these particular triangles, and it will be dividing it again and again and again. Right. So every time it creates a vertex and it will draw a triangle. It creates a vertex, it will draw the triangle. Every time it does the same. Right. Every time, whenever it is doing, it prints in this way. Right. So this is the example value of my 1 division. Right. So how does it look with division 2? We'll try to understand. We'll try to understand that. All right. So we'll run here. So taking it as the second one. So in the second, how many divisions do we have? So this was the primary tetrahedron. In the primary tetrahedron, then I have the first division over here. This is my first division, and inside there we have the another division. So first division and second division. So similarly, you can actually go with many terms or how much ever divisions you want. Let me give 5. It will be difficult already to go through how many divisions you have. This is 1, 2, 3, 4, and 5. If you expand it further, only then you will be able to see it. Okay. So if you want to slightly tilt the particular tetrahedron, if you want to slightly tilt the tetrahedron, basically this is actually apex tetrahedron. Okay. The best tetrahedron, I think I have it over here. So this is how exactly the value looks. Okay. So my example is here. So this is your apex. All these three are the sides. So this is side 1, this is side 2, and this is side 3. So this is red, this is green, and this is black, and on the bottom you have the green. So this is how exactly your application is. All right. So the next question is, what if can I give 50 as a number of divisions? Yes, you can give. There's no restrictions, but the image will be very, very, very delicate, and it takes much time to execute because number of divisions, and you know what is recursive, right? This is what happens. See, I didn't get the output, but still it is doing its job. It is still calculating, right? That's why I told you restrict your number of divisions to 0 to 5 so that you can at least explain the examiner that this is how exactly the program looks. All right. So yeah, it will not come so soon. So what I'll do is we'll close it. Okay. Okay, let's give the division as 10. I think the division of 10 will be pretty given straight, right? So this is the 10 divisions, right? All right, try it out with many more programs with the case. I'll just show you the Seiperniski gasket. How beautifully they are, right? So with the images, right? I'll just go with the images. So these are the Seiperniski gasket based. Practically, this is what we did. This is what I actually did. So this is your 1, 2, 3, 4, 5, 6, 7, maybe 7 different divisions are there in this gasket. Okay, so many gaskets are there. So basically, it's not only a gasket. You can also go with cubes, right? But with the triangles form of this, um, pretty basic stuff. A very simple program which we saw, right? So if we go look for any GIF, you'll be getting few GIFs also, how the divisions are made. Okay. So basically, it's also you can also create a rotate. If you use a rotate functions, you can rotate its particular axis. You also get very beautiful applications also. This is basically one GIF, which is actually dividing 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divisions. So gasket is what it is. All right. So that's about the gasket program and applications. So this is how the divisions are made. So second division, third division, fourth division, and it goes on. As it goes on, the hollowness within the application can be pretty much seen. All right. Okay then. So this is the end of this session.